In this video, we're going to be graphing exponential functions, and we're going to start with the parent function, f of x equals 2 to the power of x. That's the parent right there. And then we're going to figure out how to use nice exponents to find nice coordinates so that we can sketch the graph really quick. Okay, let's start with the parent function. I have made a table of value to save time. You can easily figure it out if you do. Let's see how we figure out this one fast. 2 to the power of negative 3 is 2 to the power of is 1 over 2 to the power of 3, because negative says to take the exponent reciprocal of the base, and then we can do that's 1 over 8. So you can pause the video and try to figure out how I did the rest of them because of time, and then now we can go ahead and graph these points. The first point is 3. I want to start from the bottom. 3, 8 will be over here. 3, 8 will be over here. 3, 8, and then 2, 4, and so on and so forth. If I graph all the points and connect them with a smooth curve, I'm going to get something that looks like this. The graph will look exactly like that. Okay, there is something interesting about this graph. As you approach, as your value x value is going towards more negative number, getting lower and lower and lower and lower, you're getting near 0, getting near 0, getting near 0, but not quite getting to 0. You're never going to reach y equals 0. That line, y equals 0, is a line that the graph is approaching but never touches. As x becomes extremely large, when x approaches negative infinity, y is approaching 0. This is called the asymptote. Is y equals 0. That's the asymptote for the parent function. Okay, we're going to need the asymptote concept to help us graph today, so pay attention to asymptote. Matter of fact, I did some work before I started recording just to get you to kind of understand what asymptote, how it looks like from the equation without seeing the graph. It's very easy to see. All right, so I graphed a bunch of exponential function on Desmos, and so let's start with the top one over here. I grabbed this yellow one over here, I highlighted. That is this graph, this black one. That's this graph right here. As you can see, that graph is approaching a new line now. It's shifted, has been shifted up. The parent function was this one. This was the parent function. Let me grab it in, let me highlight it in blue. The parent function is this one red over, because I'm going to highlight it in blue over here. That's the parent. Okay, that's the parent. That parent has been shifted up to 6 points up. 6 points up. So it's 6 points up. So is also the asymptote. It's been shifted up as well. So the asymptote that used to be y equals 0 is now y equals 6. That's the new line. I drew the line ahead of time. So I try other numbers, like did another one, this one over here. Let's erase the yellow now and make another one yellow. This one now is the one I want to focus on. Oh, well, look at yellow. This one, focus on that. That is this new one right here. All right. And you can see that the asymptote is y equals 3. All right. What do you notice from these two? You can see that, the first one, the last thing that was added to the function here, that's a constant added to the function, that is the asymptote. This constant that was added here, that is the asymptote. So, and I said, okay, let's do some negative and see what happens. So I put the parent minus 2, and guess what? This is the new asymptote now. The parent minus 2 is this green one, this one. That's this. And that is sure the asymptote. You can see that. So this is the asymptote. And then I did for -3, and that's the last one over here. -3 is also shifting down by 3. So the bottom line is that you can recognize the asymptote from the equation just looking at the last number, the constant that is added to or subtracted from the parent function. That is the asymptote. Okay, now something new I'm doing in this video for you guys is it's too much, it's a lot of talking, blah, blah, blah. I'm trying to, for those who are visual, I'm trying to create a short summary of what I'm saying so that you can pause the video and see it written down, and then you can take notes. So I have written down whatever I've discussed over here now. This is the summary of it in written form for you. You can just pause the video and, you know, take notes. All right, you're going to see this throughout this video. Let's move on to the next one. So the next thing we're going to learn now is this. So we know about asymptote. Good. That is, we can recognize it. Now, there is this concept of nice exponents that we're going to use for graphing today. All right, look at this function here. Nice means, when I say nice, it means that I want something when I plug into x and evaluate the function, I want the answer to be a whole number. So you can easily see that here. If I put 2 to the power of 0, I will get 1. If I put 2 to the power of 1, I'm going to get 2. So in a way, I'm telling you then that this 0 is a nice number to use for the variable, that because it's going to produce a whole number. So watch my color coded. Whole number will be what I'm looking for, my output. The number I should plug in to get me that is a nice number I'm looking for, okay? So here my nice number is 1 because it's producing a whole number output. All right, how about this one? If I plug in 0 there, will I get a nice a whole number output? Let's see. If I put, let's work it over here, 1/4 to the power of 0. Well, anything to the power of 0 is 1. So pretty good. So output is whole number. Input nice number 0. Good. There's nothing to do. Now, what if I plug 1? If I put 1 here, let's try it. If I put 1/4 to the power of 1, oops, that's not a whole number. That's a fraction. So 1 is not nice. It was nice for a whole number base like 2, but it's not nice for fraction base like 1/4. So I'm not going to use 1. Now you can imagine what I'm going to use now. So what if I used 1/4 to the power of -1? Well, the -1 says to flip the number, so I get 4. So that means 4 is a whole number, and the nice input that gives me that is a -1. I highlighted the nice number is -1. It is what I just said, you know. Pause, take notes, is everything written down for you there. What if I have something that is not just a variable by itself? It's an expression in the exponent, like this. X minus 6 is an expression in the exponent. All right, we already discovered before that for a base that's a whole number, 0 is good, 1 is good. So now, what's left for me to discover, to figure out is this. How can I turn x minus 6 to be 0? I can do it with raw mental power, like saying, well, I put 6 minus 6 is 0. So 6 is a nice variable, nice number to replace the x with. So that's just mental math, okay? But what if I want to do it another way? I can, it can get very complicated. So I can just set that number to be 0 using algebra. Because I want 0 as the exponent, because 2 to the power of 0 is 1. See? So I want to set this to 0 and then add 6 to both sides. Add 6 to both sides. And then x equals 6. So if I now write it as 2 to the power of 6 minus 6 is 2 to the power of 0, which is 1. Yes, I'm happy because I got 1 whole number for output, and my nice input is 6. I know that if I plug in something that will give me 2 to the power of 1, that will be good. So I want, another thing I want is, I want x minus 6 to be 1, because 2 to the power of 1 is 2, which is whole number. So I want those stuff over, that stuff right there to be 1. So I can just add 6. I set up the equation, add 6 to both sides, and I get x equals 7. So that when I plug it in, if I plug in 2 to the power of 7 minus 6, 7 minus 6 is 1, so 2 to the power of 1 is 2. So I got my answer. My output is 2, which is whole number, and my input is 7. That will give me that. So nice input is 7. All right. Let's go to the second one over here. What if I wanted a nice input with this one? Well, I know that 0 works. If I have anything to the power of 0, I'm going to get 1. So I just need to figure out x plus 5 has to be 0, because 1/3 to the power of 0 is 1, which is good, which is whole number. So, but now I need to solve this equation to find what x must be. So x has to be -5 if you subtract 5 from both sides. So a nice input is -5, and that will give me a nice output, or a whole number output of 1/3 to the power of 0, which is 1. So when the input is -5, the output is 1, which is good. Now a -1 here. All right, so that will be -5 minus 5, s equals -6. So if I use 3 to the power of -1, 1/3 to the power of -1, because if I put -6 here, -6 plus 5 is -1. So 1/3 to the power of -1 is 3. So for an input of -6, my output will be 3. All right, the note for that, it has everything. Pause, take note, I'll study it. So I want to graph this. I need two things. First thing is, I want the asymptote. All right, and the asymptote here is y equals 3, because that's the number that is added to the parent function. Okay, I also want 2 points. I need 2 points. So the 2 points, one like that and that one like that. I just need to figure out what to put into those places, and I'll be able to make my graph. So now let's find out something I'm going to use with a base that's a whole number. Well, a 0 will be good. What am I going to use with to get x minus 5 to get 0? Add 5 to both sides, x equals 5. So 5 is a good input to use. So let's say I use 5 as a good input. Let's see what the output will be. Be careful. So I'm going to find f of 5. F of 5 will be 2 to the power of 5 minus 5 plus 3. See, I have to plug it in carefully. And then I have 2 to the power of 0 plus 3. And then the answer will be 1 plus 3, which is 4. Okay, now let's go back to my color coding. When I use an input of 5, my output will be 4. Guess what? That is the coordinate I'm looking for. 5, 4. I got one of them. Yay. I need this space to do the work for the other one. It's just the same work. I encourage you to pause the video and do the work that I just did over here. Do the same work here and see if you're going to get the same coordinate I'm going to get in this space here, okay? I want x minus 5 to be 1 because it's a whole number base. I like the base. This is the base. It's a whole number. So if I use 1, it will be 2, okay? So now let's solve this equation. Add 5 to both sides, so x will be 6. X is going to be 6. Here you go. That's my input. Now let's find f of 6 now. F of 6 will be, well, that will be 2 to the power of 6 minus 5 plus 3, which is 2 to the power of 1 plus 3, which is 2 plus 3, which is 5. So if I plug in 6, I'm going to get 5 as the output. So I got my coordinate. If I plug in 6, I'm going to get 5. There you have it. Now I have the 3 things I need in order to sketch this graph. So let's go ahead and sketch the graph now. So I need to draw the asymptote first. Y equals 3. Let me use my ruler to help me draw it. Y equals 3 is the asymptote. I draw it. All right, let's use green to draw it. Okay, asymptote. Okay, it's kind of faint, but that's y equals 3. That's the asymptote. Now I need to plot 2 points, 5, 4. 5, 4 is right there. Not quite good. And then I'll do 6, 5 is right there. Now I can see the graph is coming along. Let's use red to draw it. I can see it's going to run along the asymptote, right? And then it's going to start rising up, and then it's going to start going up. That's why I just need 2 points. If I want to be more precise, I can do 3 points, and then look for another maybe 2 to the power of 2, 4, and things like that. So, but for right now, for this scale, just be able to sketch 2 points and the asymptote. You can make a kind of guess of how the graph is going to look. That's more important for us. The reason it's more important is we want to know the domain and the range. If we're able to sketch this, I can tell the range. The range for this graph is going to be from 3 to infinity. Because it doesn't go below 3. So that's the purpose of just sketching it to get the domain and range. And the domain is all real numbers. So we're going to get to that later on. All right, here is the note for that. And then here is the new one. This one will be faster because you already got the idea. All right, so I want x plus 4 to be 0 because 0 is good. 1/3 to the power of 0 is 1. So I want x to the power of 4 to be 0. So that means that if I put x plus 4 is 0, x has to be -4. So I'm just going to do f of -4 straight away. F of -4 will be -2. Be careful when you are substituting like this to make sure you do it correctly. So -4 plus 4 minus 3. Don't forget that what is tagged on here, okay? So it'll be -2 times 1/3 to the power of 0 minus 3, which is -2 times 1 minus 3. Now I'm going to do order of operation, okay? We do order of operation. -2 times 1 is -2 minus 3, and the answer is -5. Okay, so I got 1 point. Remember, if I use -4, I will get output of -5. So I want to write my point up here and say, well, my point is -4 will give me -5. Okay, I need 1 more point. Let's do it. Okay, so let's do it. I want -1. Do you know why I want -1? Because it's a fraction base. If I do 1/3 to the power of -1, I'm going to get 3. So I need x plus 4 to be -1. So I need x to be -5. So I can find f of -5 to be -2 times 1/3 to the power of -5. See, I already plugged it in. And then minus 3, which is -2 times 3. It's a -5, -1. I'm sorry, it's a -1. Because -5 plus 4 is -1. And then 1/3 to the power of -3, -1 is 3. Okay, I'm getting tired. So this is -6 minus 3, which is -9. Whew. So input, you can tell I'm tired. I don't know why it's doing that. It's wasting too much time. Input is -5, and the output is -9. And now it's -5, comma, -9. Now we're ready. So let's try the asymptote. The asymptote for this is y equals this last number, -3. We got the 3 things that we need. So let's quickly graph it. I draw my asymptote. Y equals -3 down here. Okay. Okay, that's my asymptote. Y equals -3. And then I plug my point. -4, -5. -4, -5 will be over here. And then -5, -9, -5, -9 will be right there. Okay, you can see that the graph is going to go along the asymptote. So the only way to go would be to go like this. It has to go like that and then turn and then go like that. Okay, so like I said, the goal of this is to be able to sketch this, because later on I'm going to ask you to find domain and range. As soon as you can sketch it like that, quickly you can tell what the domain and range is. Until the next time, keep getting high on math.